Hello and welcome. We are now going to use the third way to solve Crack Me 13, and there are actually two ways to do the third way. One way is to unpack it first and then do the serial phishing on the unpacked file, and the other way is without unpacking, straight away go and do the serial phishing. So the difference between serial phishing and file patching is file patching, you don't care about the serial key. You patch the file to bypass the serial key. So in here, you are actually trying to find out the actual serial key. So generally this is more difficult to do than the previous two methods. So let's try it now. Let's open the pack file. I'm not going to unpack it. Just open the pack file with x64dbg. And over here, click on Plugins, Scylla Hide, Options. Make sure that you have loaded the basic profile so that you can hide the debugger from the program. So now let's run it and key in any serial key. Click on check, and now we are going to find out the memory address where the string is being compared. So to do that, we are going to use the call stack method. So we'll pause it here, and once the debugging is paused, click on the call stack and look for the memory address where the user module makes a call to the system to show the dialog box. So this is the location. Right click and click follow from, and if you scroll up now, so this is the location where the call was made to show the dialog box. And if you look up further, you will find there is a jump here, and this is the jump which decides whether to show the good message or the bad message. So this is the comparison being made over here. Just before a jump, there will always be a test or a compare. In this case, it is a test. So the result of this test determines whether or not to jump. So in here, we can put a breakpoint to see the result of the test. So now we can run, and then over here click OK, click check, and now it has hit our breakpoint over here, and you can see the result of ESI is -1. Remember, all F means -1. So we can put a remark here that ESI should be 0, because test ESI means you are testing whether the value of ESI is 0. If the value of ESI is 0, then it will jump. If the value of ESI is not 0, this will not jump. So that is why here we can put a remark. So over here we can put a remark, say ESI should be 0. Click OK. So now as it stands, ESI is not 0 since it's -1. So our clue is ESI. We need to hunt down ESI to see which instruction sets it to -1. So if you look up here, you will find that ESI is being set by this instruction, EAX. So EAX here sets this. So now we put a breakpoint further up, and then we run, and then now click OK and click check again. Be sure not to reset. If you reset, you will lose all your breakpoints because this file is a pack file. So now we are hitting our a new breakpoint, and we examine EX, and we find that EX is -1 also. So now our new target should be EX. So put a comment there and say EX should be 0. So now we managed to trace the value of ESI to EX. So it is EX which ultimately decide the value of ESI. So now over here, we can trace what sets EX. So it seems there is a call just before this. And normally the result of a call is stored in EX. So it's a good place to examine. So we can put a breakpoint here. And now we run again. And then we are going to enter this call to see what happens inside here to set the EX value. So to run again. And then come here, click OK, and click check again. So now it has hit our new breakpoint, and we can press F7 to step into this call to examine what sets the value of EX to -1. So let's press F7 now, and we are inside the call. And now you examine the value of EX and keep pressing F8 to see when it becomes -1. Keep pressing F8. Now it's 1, F8 again. Now it's -1. See this, all F means -1. So it is at this line that EX becomes -1. And just before it, there is a call to compare string. Yes, so this is a good place to examine what happens. And this obviously is API, so we can select all this part here, right click, and then select X Analyzer, Analyze Selection, and we see this is the API call, and the API accepts all these parameters, and we notice that there are two strings which are being used to compare to each other. And we can look up this in using Google Chrome browser, compare strings. Select the first result, and you see compare strings compares two strings, this string with this string, and then returns the result here. So the result is normally in EX, as you recall from previous lesson. So compare string will compare this string with this string, and then you return the result in EX. And so this is a good place to put our new breakpoint over here. And then we run again. And then here, click OK, click check again. Now we hit our first breakpoint. And so we should enter this call, run, and now we hit our new breakpoint. So over here, now we can examine the stack as it is being pushed. Press F8. Now we are here, press F8, and it has pushed the first string into the stack. And you can see the string is ABC-1234556. Now if I had to guess, I would say that this is the serial key. Then now it's here, it's going to push a count, which is E. Doesn't matter, don't have to worry about that. Now it's going to push another string. Press F8, and you see the next string is pushed. So it is going to compare this string with this string. Keep on pressing F8, and now if you press again F8, it will store the result of the comparison in AEX. So press enter, and the result is 1. So what is the meaning of 1? So let's go and examine the MSDN, the return value of this function. If you scroll down, you will see it returns the value described for this. So click on this, and then here go down to the return and look for the return value. So it returns one of the following values if successful, either this value, or this value. So these are all constants. So it seems that it is returning 1. 1 could be this or this or this. But I don't think it is this, because this means equal. And then if you read on, you say to maintain the C runtime convention of comparing string, the value 2 can be subtracted from the non-zero return value. So if you subtract 2, and you will get the same result as the standard C program. Now this is Microsoft compare string. Microsoft compare string does not return 0 if the string is equal. It returns 2. How do I know that? Because you are supposed to deduct 2 from the non-zero return value. So if the string is the same, it will return 2. So let's look at this. Go back to our code. It is returning 1. That means the string is not the same. If it's the same, it is supposed to return 2. So now if you go down here, let's see what happens. You press F8 and see it is going to minus negative 2. It is going to minus 2 from EX. Adding negative 2 to EX is the same as minusing 2 from EX. So this FFFF ending with E means negative 2. So this is consistent with the MSDN. MSDN say when the value 2 can be subtracted from a non-zero return value. So if the string was equal, after you minus negative 2, you should get 0. So you press F8, you will see that it will not be 0, it will be negative 1. Because negative 2 plus with 1 will give you negative 1. Right? It's the same with 1 minus negative 2. So now we know that EX is set over here, and definitely this is the password, the serial key. Right? We can test our theory. We can run the program again and try to enter the serial key and come back here and see what happens. So the serial key is ABC-12345 So you can copy this out by selecting any of the previous line which contain the string, and just copy this line, and paste it in your notepad. And then over here, just delete. And this one is the serial key. Click run again. Click OK. Now we enter the serial key, the correct one, and then you click check. And then over here, now we are here. Click run to enter the call, and over here now you press F8. You will see now it is pushing the string. This is the string that is to be compared, and you push another string. So now both strings are the same, and then keep on pressing F8, and after the call to the compare string, you will find that EX is 2. So that confirms the SMMSDN, which says that if the string is equal, it should return 2. Right, so now if you keep on pressing, it is going to minus 2 from 2, and that should give us 0. Right, so you press F8, and true enough, it has minus 2 from 2, and it gives us 0 now. So now, if you keep on pressing F8, remember that when you're adding, you take the source, add to the destination, and store the result in the destination. So that is the reason why when you take negative 2, add with 2, you get 0, you store 0 back in the destination. So now if you press F8, continue to press F8, come back here, EX is now 0. And that confirms with our command which we wrote earlier. Keep on pressing F8, and now ESI should be 0, and true enough, you see ESI, it is 0. So now if you keep pressing F8, it will jump to the good message. And now you can just click run, and you will see it has shown the message correct key. So this is how we do serial fishing to fish out the serial key. Now in this example, it so happened that when you run it, the serial key is already been detected. So for example, when I run it again, if I put in a wrong serial key, if I were to put in a wrong serial key, let's say, and then I come here, you notice that the serial key is automatically detected and shown here. So in this example, we are so lucky that we already can see the serial key being detected by x64. Sometimes in certain software, you might not get so lucky. The serial key may not be so easily detected over here. So that is why I went through the trouble of explaining to you in great detail how to hunt down the serial key and extract it. So that's all for this lesson. Thank you for watching. I'll see you in the next one.